remove an element from a queue, you remove it from the front. Okay, so it's just like you go to Hang Seng Bank and someone is queuing, okay, in a line. When you join the queue, okay, you must join at the back. You won't go to the front. Okay. So when one of the counter is available, then the customer at the front of the queue will receive service. So it's first in, first out. Now in a queue, okay, this will be the set of operations. Okay, so there's one function to initialize the queue to the empty state. Find out the size of the queue, so how many elements are there, okay, in the queue. To test if the queue is empty, okay, to get the value at the front, okay, so to get the value of the element at the front. The other function is to get the value of the element at the back. The push function, okay, in the C++ STL terminology, okay, it uses push for inserting an element at the end. In some other languages, this function is not called push, it is called enqueue. Or it can be called push back, okay, push at the back, okay, of the queue. Now to remove, okay, the element at the front, okay, in the C++ terminology is also called poke, but in some other languages we call dequeue or delete, okay, or poke front, okay, so there's several different possible names, okay, but the meaning, okay, are the same. So once again, for the push function, there are two versions. One is to receive the items as a L value reference. The other version is to receive the item as a R value reference. Okay, but the body of the function are, okay, syntactically, they are the same. The only difference is the way that, okay, the item is passed to that function. Now in the program, when we implement a queue, very seldom we will use a linear array to implement a queue. Okay, now why we don't use a linear array? Now if you have a linear array, okay, the indexes of the linear array is from 0 to n-1. Okay, so if you keep the element, okay, at the front is close to the index 0. Okay, so initially you may have some members in the queue. Okay, now you have the front and rear. Okay, and in your application, you will put some new item into the queue and remove some existing items. Okay, so sooner or later, okay, both front and rear, okay, will be moving towards the right hand side, okay, of the array. Okay. Now you have some items here, and this part of the array are empty. Okay. So if you interpret the array as the conventional linear array, and you want to add one more item, okay, at the end, you find that, well, you don't have the space at the end. Okay. One simple solution is that now let's copy the data from the right hand side to the left hand side, and after the copying we do the insertion. Now this type of copying is unnecessary and it is time consuming. Okay, so we can avoid this copying by interpreting the array as a circular structure. Okay, So when we fill up the array towards the right hand side and make one more addition, we roll over to the leftmost index. Okay, so we interpret this array as a ring, just like your watch. Okay, so when the needles move to 12 and the next movement will be back to 1. Okay. Now, if we interpret the array as a circular structure, we need to keep certain conventions. Now, in the queue, we maintain two indexes, front and rear. That refers to the first element and the last element. Now, when we have a circular structure, we assign a value to the index. The index will always be within the range from 0 to n-1. Okay, it is not appropriate to give a negative index to a ring structure. Okay, now we will use one special case. Whenever front is equals to rear, then it means that we don't have any data items in the queue. Okay, and logically, the rear index is pointing to the last element in the queue, and the front index is not pointing to the first element, but instead it is pointing to the empty slot before the front element. So it means that when you have one element in the queue, front and rear will not be the same. They will have different values. When front and rear have equal value, then it means that the queue is empty. Okay? Now this is the convention, that is being used in general. Now, because of these properties, front is pointing to an empty slot. So if you fill up, the other slot of the array and rear, move to the last position. For an array of size n, you can only store n-1 items. You cannot store n items. Once you put in n items, then front is equals to rear, and then the program cannot distinguish the case that whether or not you have n items or the queue is empty. So that's why in this case, for an array of size n, it can only store up to n-1 elements. Now the implementation of the queue class will be like this. In the class, we use an array for storing the elements. It has a physical size. The array has a physical size. And we maintain two index, front and rear. Now, when the queue is created, that is initially is empty, both front and rear is assigned the same value. So we can set it to 0. It will be the same if you set it to 1. It has no difference. Now, to initialize the queue to the empty state, then both front and rear are set to 0. To test if the queue is empty, you compare front and rear. If they are equal, then the queue is empty. If they are not equal, then the queue is not empty. Now to test if the queue is full, Now, the way to do it is that you rotate the where pointers by 1. Okay, so you add 1 to where and take the modulo of max size. If this value becomes equals to front, then you cannot put in one more item. Okay, then the queue is considered full. Okay, because now in this case, front and rear, okay, rear is catching up, okay, after 1 through, okay, revolution, it is catching up to front. Okay, so you cannot put in, okay, an element to the last empty slot. Now to find out the size, that is the number of elements in the queue. Then you will take the difference of rear minus front. Now, but rear and front, okay, it can be, okay, it is not necessary that rear is always greater than front. Okay, you may have the case that it is all rotating. Okay, front is at the, okay, right hand side and rear is on the left hand side. Now to overcome this possible negative value in the subtraction, you add back the value of max size and then take the modulo. Now the assignment operator is very similar to the case for the stack. Okay. So if this is not equals to other, then you copy everything from, okay, the queue, from one queue to the other queue. Now to do the push, if the queue is not full, you rotate the where pointer by 1 in the clockwise direction. Okay, you rotate it by one slot. You add 1 to it and then take the modulo of max size. After that, you place the item in that position. Okay. If the queue is full, you have the queue overflow problem. Or, alternatively, you can expand the array, copy the old content. Okay, then you accommodate the push without causing the overflow exception. Now for the front method, okay, that returns the value of the first data, okay, in the queue. Now the front pointer, okay, the front pointer is pointing to the empty slot before the first element. Okay, now you see that the front pointer is pointing to the empty slot before the first element. Okay, now to get the value of the first element, you need to add 1 to front and take the modulo. Okay. Now you will return this item by reference. So that's why the precondition for calling the front method is that the queue must be non-empty. Otherwise, you will get an error. Now for the pop, okay, for the pop function, then if the queue is not empty, okay, then you will update front, rotate it, okay, by 1 slot. Okay, but in the pop function, there's no return value. Okay, so you don't need to do other things. Now, if the queue is empty, okay, then you will have the queue underflow error. Now, the copy queue function will be similar to the case of the copy stack. The difference, only difference is that now you are copying data in a circular manner. Okay, so in the loop, okay, then you start from front And as long as you have not reached, okay, the where, within the loop, you rotate I by one position. Okay, and then you do the copying. Okay. So after this rotation, when you get back to the while statement, if you have already copied the data at the where, then it means that you are done. Okay. Now, in a program, a queue can be used in a few applications, typical applications, like in computer network. Okay, when you have multiple processes that exchange data, okay, then the data will be buffered in a queue because you want the message to be delivered in a first in, first out manner. Now the other applications will be in the operating system for task scheduling. Okay, so most of the time the tasks are scheduled in the first come first serve. And the other application is that if you have a multi-dimensional data structures and you want to perform a breadth first search, then you will use a queue, okay, in the search function. Or you will use a queue in an event-driven simulation. Okay, that some event will be generated, okay, at a certain scheduled time, and then you put that scheduled event into a queue. Okay, and these are the typical uses of queue in the higher level application. We will see some example later, okay, when we discuss the topics on trees. Okay.